Hey folks, now that we've talked about scalars and vectors, we're going to go into kinematics some more and talk about position, displacement, and distance. We're going to try and understand what these terms mean and also how to use them. We'll get right started with position. Position is your location. So location in relation to a reference. Now, a reference in physics is basically when you are solving a problem or analyzing a situation, you decide where zero is on your diagram. And that tells you where everything is in relation to that. The variables for position, there's a lot of them because we live in a three-dimensional world. The most common variables for position are x, y, or z. When we start to consider things in literal outer space, or also things that move in a circle, in other words, say the same distance away from a single point, we're going to use r for position. Now that you're seeing these arrows here, you remember from our last lesson that that means that position is a vector, so the direction matters. The units for position are the meter, which is a lowercase m. So in terms of position, you can think of things in one dimension on a number line. And so this object here would have a position of x equals -3 meters. So the negative can mean a lot of different things. It can mean that it's 3 meters to the left of 0, 3 meters behind 0, 3 meters under 0, 3 meters south of 0. It depends on the context of the problem. Okay, so that's where something is. Displacement starts to get into how it moves. Here we go. Displacement is defined in terms of position, so it's defined as the change in position. And when we use the phrase change in a science class, we need something very specific, and I'll get to that later. It tells you the math that you're supposed to do. Also in science, we use Greek letter delta to mean change. And so the variables for position are going to be delta x, or delta y, or delta z. And then for whatever reason, we tend to not use delta r for displacement, mostly because of the way that's given. We don't measure a change in radius relative to a point. Again, these three variables have arrows above them, and so displacement is also a vector. So we can have a positive or negative displacement or zero. Units for displacement are the meter also. Now, displacement, because it's a change in position, it comes with a calculation. So if I'm computing the displacement delta x, then the way you compute a change in all science classes is the same way. You take the final value of that quantity, and then you subtract from it the initial value of that quantity. And so these two variables, xf is final position, and xi is initial position. Initial position being where it started, final position being where it ended up. And so to calculate displacement, we only need those two values, where it began and where it ended. You would always do final minus initial. As far as like calculating a displacement, you just have to keep track of like the order in which you're calculating things. So if we know where 0 is, we can set up a number line. +1, -1, so all the hash marks are worth 1 meter. And if I have an initial position here and a final position here, displacement being a vector, I can represent it with an arrow pointing in the direction that the object was displaced. And so this is moving from right to left on my number line. That's a clue that the displacement is going to be negative. So I can now calculate this. And just plug in the values of position that I have. So the final position was at -2. And I'm going to subtract from that the initial position, which was positive 1. And so this displacement is negative 3 meters. So to move from positive 1 meter to negative 2 meters is to have a displacement of negative 3 meters. So in this case, on this diagram, it means that this object moved 3 meters in the negative direction. Okay. The last thing about displacement is that you will see a couple different ways to write initial and final variables. So after like today, you are not going to see me write final and initial that much, but you are welcome to continue using final and initial. It's very clear what you're communicating. The way that you're going to see me use final and initial is I will put no subscript on the final value of something, and I will put a 0 subscript below the initial value. So final position in this case is x, and then initial position, we got to talk about that. So x0 is pronounced x naught. And so that's a funny thing to learn, but x naught is what we would call x0. And the meaning of x0, it is the position when t equals 0. So in other words, if you are timing this event, then x naught happens when you start your stopwatch. It is when the problem begins, or when you are starting to analyze that situation, that moment. So x naught is when the timer begins on your problem, and then x is when the timer ends. Okay, so that's displacement. Distance is up last. Distance is a little simpler. It is the total length traveled. And it is different from displacement in a couple key ways. The variable for distance is just a lowercase d. There's only one generally for distance. Now there's no arrow above that symbol, so we know that distance is a scalar quantity. And then the unit of distance is the meter. So everything today is in meters. And we'll look at the difference between distance and displacement with a question. If I walk 40 meters north and then 50 meters south, what is my displacement and what distance did I travel? So if I start with displacement, this tells us that we walked 40 meters north. It doesn't tell us where we started. So as a physicist, we have to like make something up or imagine where something started. So we're going to imagine that we start at 0 meters. And if we're going north, north is generally the positive direction. And so we're going to end at positive 40 meters. If we then go 50 meters south, we start at positive 40 meters. And then if we're going south, south is generally thought of as a negative direction. We go 50 meters back in the opposite direction. We go all the way back to 0, and we end up at negative 10 meters. So one thing that you need to do in these problems is transpose between direction and positive and negative numbers. The displacement is now easy. It's final minus initial. The final position is negative 10 meters. The initial position was 0 meters, and so this is a displacement of negative 10 meters. Now the negative here means in the negative direction, and south is the negative direction. So you could also say the displacement is 10 meters south. For distance, we just add. Distance is something that only ever adds up. It starts at 0 and it counts up as long as an object moves. So the distance is, the first leg of this journey is 40 meters. And the second leg of this journey is 50 meters. So the total distance is 90 meters. Distance is something that like your car's odometer tells you how many miles your car has traveled. If you have a step counter, or if you're a runner and you have a running app, it tells you how far you have run. And so we'll explore these ideas and add time to the mix in the next couple of videos.